Rachel here with New York Bioforce, and today we're going to use our micropipetting skills to make some 1x dilutions from 10x stock solutions and to mix some of our 1x solutions to come up with some new products. So the first thing we're going to do is dilute our 10x solutions, and to do this we're going to do a little bit of math that is really common in a biology lab. So here's a table of what we're going to be making. What I have are 10x stock solutions. It's very common in a lab to have a more concentrated version of the solutions you normally use. And we're going to dilute these down to final solutions that are 1x, and those will be called our working solutions. So the 10x equals our stock solution, and our 1x equals our working dilution or solution. And I've already done the math here, but I'm going to just demo for you how I got to these numbers. So a common equation you're going to use in the lab is CIVI equals CFVF. And this comes from conservation of mass, and you will have seen this in your physics classes as M1V1 equals M2V2. That's usually the first place we see something like this. And this is how we're going to figure out our dilutions. So C stands for concentration. V equals volume, little I equals initial, and little f equals final. So I'm just going to do an example of how we figured out our blue tube that we're going to make. So I'm going to transfer this over here. So I'll put this equation here again so we remember CI times VI equals CF times VF. So our initial concentration of our blue solution is 10x. So we have a 10x, that's our stock solution. So I'm going to put a little x there. The final concentration we want is 1x. And the final volume we're told that we want is 1,000 microliters times 1,000 microliters. So what we don't know is what initial volume of our 10x stock solution to put into this volume to end up with that. That's what we're going to solve for. So I'm going to put this V here for our unknown. So from here, to figure out what this unknown volume is, we just do simple algebra. We're going to divide both sides by the 10x concentration. That's going to cancel out. Our unit cancels out here, and we end up with 1 times 1,000 divided by 10, which is going to give us this V unknown as 100 microliters. That means I need 100 microliters of my 10x solution in this final volume of 1,000 microliters to end up with a 1x solution. So the last little part, so that's how I got this 100 microliters of 10xi here. The last little part is to know how much of our diluent, in this case water, we need to add to end up with our final volume. So our final volume is 100,000 microliters. It's our final volume. We're going to subtract the 100 microliters. That's going to be our 10x stock solution, and that's going to give us a total of 900 microliters of DH2O, that's distilled water, that we need to add to make that final volume. So if we take this all together, that means I need 100 microliters of 10x blue plus 900 microliters of DH2O to get a final concentration of a total of 1,000 microliters of 1x blue. All right, so I've done that for 3 separate volumes. This is what we did in our class. We figured out the math using the same equation, and so this column here is the volume we need of all of our 10x stock solutions. This is the volume of water that we need to add to that, and this is our final volumes of each of those in our 1x concentration. So I already pre-labeled all of my tubes. I labeled on the top and on the side 1x red, for example, my initials and the date. And now we're going to add, make each of these 1x solutions. So I'll pop all these tubes. So I'll start with just the blue one that we just figured out. When you're making diluting solutions, usually you want to start with the water or whatever you're diluting into, and then add in your concentrated stock solution. So I'm adjusting my pipette to 900 just by spinning the top. There we go, so 900. I'm going to put on the correct size tip. And then I have my water here. So again, I push down to the first stop, and then I place it in the tube, slowly draw up. Notice that I'm keeping my pipette straight up and down. You don't want to be tipping it sideways because then your liquid can get caught up in the higher in the tip. And then I'm dispensing this into my blue tube. I double check the label, 900. And on dispensing, I push all the way down to the bottom to get any last bit out. I eject my tip by pushing with my thumb on the side. And then I need 100 microliters of my 10x blue. So I'm going to set this down for a minute. Here is my 10x blue stock solution. And I'm going to adjust this pipette now to 100. And remember, this pipetter only goes up to 100. So that means that that last number there is a decimal point. So up we go. You only ever want to use these pipettes in the range of numbers it's given for accuracy. So this is between 10 and 100. So while I can take this a little bit past 100, it won't be accurate. It's only calibrated up to the number it says on the top. So take that down to 100. So this is going to be a smaller tip. So again, I push down to the first point, submerge my tip, slowly release my thumb to draw up pressure. Double check, I make sure that it looks like there's liquid in the whole tip, and it is. And then I'm going to put my tip into the water. I'm going to pipette up and down a couple of times so that I thoroughly mix this. I only go to the first step when I do that, and then last, when I'm ready, I push all the way to the bottom, pull my tip out, and eject. And so then this is my 1x blue solution. And if I compare that to my 10x, you can see it is much more diluted. It's about 1/10 of the concentration of this, or not about exactly. So then I did this before. We actually have, instead of doing that with all of them, so these are our other examples of our green, our blue, and our red. Let me put this. And you can see, we had different volumes that we wanted for each of these, and they're all slightly different volumes. So that's the first part of this exercise. So the second part now And sorry, there's one more part to that. So this is one I made before. If I compare the one I just made, they should be the same color and the same volume, and indeed they appear to be. So if this one that I just made, if I'd pushed all the way to the second stop and drawn up, it would have been higher. And if I had released my pressure off my thumb from the first stop, it would have been lower, but that is accurate. So now, the second part of this exercise is to make colors, new colors from our stock solutions. So here we have 4 new tubes. Again, I pre-labeled them. 1, 2, 3, 4 with my initials, the date, and the number. And we're going to take our 1x stock solutions and we're going to add them in these concentrations that are listed here to make new colors. So 1 is going to be orange, 2 is going to be purple, 3 is going to be cyan, and 4 is going to be an olive color. So I'm going to show for number 4, because we're using all of the colors here to make an olive green. So first we're going to take our green 1x solution and we're going to do 27.5 microliters of that. So I'm spinning my pipette down to 27.5. So remember, because this only goes up to 100, I know this 4th place is a decimal place. So 27.5. And I'm going to take my green 1x solution here. And I'm going to pre-open this. I'm going to actually tuck these in my hand. So I have my empty tube on the left-hand side and my tube that I'm taking out of on the right. So I push down to the first stop, submerge my tip, slowly draw out. There's my 27.5 microliters, and I push that down to the bottom. I push all the way to the second tube and eject my tip. I close the green tube because I'm done with it, and now I'm going to do 50 microliters of my yellow. So I spin my pipette to 50. I still have my tube that I'm mixing into in my hand. And this is yellow. So I'm drawing out. Again, first stop, submerge my tip, slowly draw out. I'm going to close this and set it down. And then, because I'm mixing, I'm putting my tip in, and I'm going to pipette up and down several times, going only to the first stop to thoroughly mix that color. When I'm ready, I push all the way to the second stop, pull my tip out, and eject. My third is red, 57 microliters. So I adjust my tip up to 57.0. I grab my red tip. Again, push to the first stop, tip in, slowly draw out. I'm going to close that and just set it out of my way. And then again, I put my tip into the liquid. I pipette up and down several times to mix it thoroughly, going only to the first stop, and then at the end, push all the way to the second stop, remove my pipette, then release my thumb and eject. And last but not least, 12.5 microliters. So I'm spinning this all the way down of my blue. All right, so 12.5, new tip, grab my blue. So when you're pipetting small volumes, it's often nice to get these tubes where you can see them and make sure that your tip is actually going all the way in and you're drawing out the liquid that you think you are. So again, first stop, tip in, slowly draw up, double check and make sure that I have liquid the whole way down with no bubbles. And then I'll put this out of my way And then I put my tip in and pipette up and down several times to thoroughly mix my color. And then when I'm ready, all the way to the bottom and eject my tip. So now I have an olive green color, and if I look at a sample that I previously made, I can again check the color and the volume and make sure that I pipetted accurately. And it appears that I did. So it's the same type of idea was done for the other colors. So we made a cyan mixing green and blue. We made a very small volume of purple by mixing our red and blue. And then finally we made an orange mixing our yellow and red. And that is the basics of accurate micropipetting and a fun little exercise to practice and ensure that you're doing that correctly.